This topic we will cover function applications. Functions are useful in solving real-life applications that can involve finance, food, entertainment, business, athletics, and many more. We'll start by setting up a notation that deals with the price of eggs. Let the cost of purchasing 3 dozen eggs be represented as the function P of D, where P of 3 is equal to $10.50. D equals 3 is the input and represents the number of dozens of eggs purchased. $10.50 is the output and represents the total cost of 3 dozen eggs. Let's analyze this diagram over here. So we're going to take 3, that's the dozen of eggs that we're going to put in here. So we put 3 dozen eggs into this. And we are referring to this as a device and for the purpose of our diagram. But what actually is happening is some arithmetic is being performed on the number 3, and the answer that comes out is going to be $10.50. The arithmetic that is being performed, we name that P. Okay, so whatever that arithmetic is, we refer to that as P, and that's an equation, or in terms of our analogy, P is a device. Domain and range. To properly solve functions, it is important to know the domain and range of the variables. The domain is the set of input variables. The range is the set of output variables. So this is the domain. All of the input variables are the domain. The range are the output variables. So this would be the range, but this is what comes out of the machine. The domain is what goes into the machine. The range is what comes out of the machine. Slope-intercept form. Applications can also be solved by creating a linear function in slope-intercept form, which is f of x equals to mx plus b. For example, in some cases, the equation can be interpreted in the following way. F of x represents the cost of the total number of units purchased. X represents the number of units purchased. M is the incremental cost of just one unit. And B is a fixed cost. It represents a fixed cost, independent of how many units are purchased. Function application, example number 1. A school drama club is selling tickets for a musical at a cost of $10 each. The auditorium has 250 seats. The amount of money collected is represented by the function m of t equal to 10t, where t is the number of tickets sold. What is the domain and range of the function m of t? The number of tickets sold, t, would be the input. Given the context of the problem, there are restrictions on t. Since the auditorium can hold a maximum of 250 people, we have to restrict t to be less than or equal to 250. But there's more. The number of tickets sold cannot be a negative number, which means t has to be greater than or equal to 0, and you can't have a fraction because the number of tickets has to be a whole number. So with these restrictions combined, we say that the domain is all the whole numbers greater than 0 and less than or equal to 250. Writing it out in set notation, we say the domain is a list of whole numbers starting at 0 and ending at 250. Now let's talk about the range. The amount of money the drama club collects is the output and the range. I'll highlight that. That's an important concept. So the amount of money it collects is the output and the range. Some output values are achievable. Others are not. Since the cost of the ticket is $10, the possible outputs must be multiples of $10. The maximum amount of money is found by multiplying the maximum number of people by the cost of each ticket, which means that if I take 250 people multiplied by $10, the maximum amount of money is $2,500. Therefore, the range is all the whole numbers that are multiples of 10 greater than or equal to 0, meaning no tickets are sold, but at the same time it would be less than or equal to 2,500. So the range is the set of numbers starting at $0 and going out to $2,500. by multiples of 10. Example number 2. Mika is having a pool party. The cost to rent the pool is $325 plus $7 per person attending the party. Regardless of how many people attend, Mika will have to pay the $325. This is the initial amount. The y-intercept, b, is equal to 325. The cost is $7 per person, making the slope m equals 7. And the cost for those attending is 7x, where x is the number of people. So the linear equation is f of x is equal to 7x plus 325. Let's talk about each individual variable and number. I wrote the general linear function right above this, so this will help us match. So when we look at f of x represents the total cost. The variable x represents the number of people. M, which in this case is 7, is the cost per person. And B, $325, is the initial fixed amount. Another thing I want to note is that the dollar amount, the dollar units, are not used in the linear equation. So use 7, not $7. Here's an opportunity for you to practice. A truck travels a distance d for time t, which is represented by the function d of t, where distance is measured in miles and time in hours. So given d of 6 is equal to 330, what does 6 represent and what does 330 represent? Pause the video, answer those two questions, and when you have your answers, resume watching the video. And welcome back. Let's see how you did. 6 is the input and represents 6 hours of travel. 330 is the output and represents the total miles traveled during the 6-hour period. Function application practice number 2. The school track and field team is selling t-shirts for $8. They have 500 t-shirts to sell. The function r of t equal 8t represent the revenue that the track and field team collects when selling t-shirts, where t is the number of t-shirts sold. What is the domain and range of the function r of t? So pause the video, determine the domain and range, and when you have your answers and think you accurately represented the domain and range, resume watching the video to compare answers. And welcome back. So let's talk about the domain. The students can sell a minimum of 0 t-shirts and a maximum of 500 t-shirts. The domain is all the whole numbers less than or equal to 500, but starting at 0. So we list a domain as a list of whole numbers starting at 0 and going to 500. So that's the domain. Now for the range, that is going to be all the whole numbers that are multiples of 8 that are less than or equal to 4,000. Now, how did we determine it's less than or equal to 4,000? Well, we start with the function r of t is equal to 8t. The maximum number of t-shirts we can sell is 500. So I replace t with 500. That's my input. And performing the arithmetic, we see that the revenue for 500 t-shirts is $4,000. That's the maximum value of the range. So when we list the range, we list all the dollar amounts as multiple of $8, starting at $0 and going to 4,000. And this is the accurate way to represent the range. Function application practice 3. Carla made an initial deposit in her bank and then added a certain amount each week. The table shows her total savings, denoted by T, after weeks, denoted by W. 2 questions. How much does Carla deposit in the bank per week? And B, how much was the initial amount at week 0? Analyze the table, pause the video, answer these 2 questions, and when you have the answers, resume watching the video. And welcome back. Let's compare answers. For part A, which asked how much does Carla deposit in the bank per week, we realize this is a linear function and has a constant rate of deposit, which is m equals 8. That's made each week. This is confirmed by finding the slope. This right here is another way to denote slope. It's m is equal to delta t over delta w. Delta is a Greek letter associated with the English letter D, and it's used for difference. So we're finding the difference in t over the difference in w. I can select any points in this table I want. For our example here, we selected 2 points which are adjacent. So we're taking the difference of 82 minus 74 on the top and 5 minus 4 on the bottom. And we see that we have $8 per week is deposited into the account. This could be found if you take any two numbers in this table and find the difference in t over the difference in w. Now let's move on to the second question. For the second question, where we want to find the initial amount at week 0, we write a linear function using the slope-intercept method. The slope, m equals 8, was found on the previous slide. Substitute one of the data pairs, 474, into the function. Find the y-intercept, b, which is the initial deposit. So a couple things. I can select any 2 points I want. I chose these two because they're the first 2 in the list, but we can select any points on this list. A second thing I'm going to add is we're going to call this column f of w. So typically this would be x, this would be y, but using our new notation, we are using, instead of x, we're using w to fit the context of our problem, and we're using t instead of y also to fit the context of our problem. Here we wrote the general equation, f of x is equal to mx plus b. As an intermediary step, I can replace f of x with f of w is equal to m times w plus b. So that's where we get this next line. F of w is equal to t, and all of that is equal to m times w plus b. Solving algebraically, we get b is equal to t minus m times w, and we make the appropriate changes. T is 74. Okay. M we calculated to be 8 on the previous slide, and when t is 74, w is 4. And performing the arithmetic, we have b is equal to 42. So we can state that Carla started out with $42 initially. Function application practice number 4. Rob is training for a marathon. Each week he increases the mileage of his long training run. Partial data are shown on the table. So take a look at the table and analyze the data. There are 3 questions you're going to answer. The first question is, how many more miles does he run each week? B, how many miles had he run before he started training on day 0? And C, how many weeks until he runs the full marathon of 26.2 miles. So pause the video, take a moment, answer those 3 questions, and when you have the answer to those questions, resume watching the video. And welcome back. Let's compare answers. The first question reads, how many more miles does he run each week? This is a linear function, as each week Rob increases his running by a constant distance, m equals 3 each week. How do we know it's a linear function? Well, if we take a look at the distance, we notice that weeks are increasing at a constant rate. We're increasing the weeks by 1, and the miles are also increasing at a constant rate by adding 3 each time. So the constant rate of change is 3. We can confirm this by finding the slope. And here we're using another notation for slope, delta m over delta w. Delta is the Greek letter associated with our English letter D, and we're using that for difference. So we're finding the difference in miles over the difference in weeks. So to do that, we select any 2 points. I'm going to take these stats right here, and I find a difference in my miles and my difference in my weeks. And that's how we get 3 miles per week. Question B reads, how many miles had he run before he started training on day 0? The process will be this. Write a linear function using the slope-intercept method. The slope, m equals 3, was found on the previous slide. Substitute one of the data pairs, 2, 7, into the function to find the y-intercept, b, which is his initial mileage prior to starting the program. So, looking at the algebra, we start with our general slope-intercept equation, f of x is equal to mx plus b. And for our specific context, instead of X, we're going to use W for weeks. And instead of Y, we are going to use M for miles. And in function notation, miles can also be written as f of W. So we can rewrite this equation as f of W is equal to m times W plus B. Now, we noted up here that f of W is equal to m. So we have m is equal to, capital M is equal to m, the slope, times W plus B. Solving for B gives us a new equation. B is equal to capital M minus m times W. Now, we selected any 2 points. Okay? Right here it says we selected 2, 7, but we can honestly select any 2 points out of this data table. But making the appropriate substitution, m is 7, our slope was 3, we calculated that, and he ran 7 miles on week 2. So we replaced W with 2. And performing the arithmetic, we find that B is equal to 1. What that means in this context is that at the start of the program, 0 weeks, he had run 1 mile. Question C reads, how many weeks until he runs a full marathon of 26.2 miles? Here's the process. Add 2 columns to represent weeks 8 and 9 and the total miles that he will be running during those weeks. Each week, Rob increases his run by 3 miles. So we take a look up here. The weeks are increasing by a constant rate of 1. Knowing that, we use that information to advance to the next column. So 7 plus 1 is 8. And continuing the pattern, 8 plus 1 is 9. We also know that this is increasing at a constant rate of 3. Using that idea, we can extend from week 7 to week 8 by adding 3 miles to get 25 miles. And then for week 9, we add another 3 to get to 28 miles. And we stop here because we have 28, and 28 is greater than 26.2. So we can stop, as we've answered the question. Rob doesn't reach the marathon length until week 9, where he actually exceeds it. Function application practice number 5. Raul is at the gas station. He is filling up his gas tank at $3.45 per gallon and is also buying $12 worth of food from the convenience store. Write an equation to show this scenario. Pause the video, determine what the equation is, and when you've figured out the equation, resume watching the video to compare answers. And welcome back. Let's see how you did. So first of all, we're going to write a linear function using the slope-intercept format. The slope is represented by the dollars per gallon, so m is equal to $3.45. The number of gallons is x, and f of x is the total price of the food and the gas. B is the fixed amount of the food, $12. And we start with our general function, f of x is equal to mx plus b. M is the change per gallon. The price is dependent on the number of gallons, and that's changing per gallon, so M is our rate of change, which is $3.45. This is a fixed rate, $12. That's a one-time fee or a one-time amount paid only for the food. So that's our B value. And that's how we get our equation. F of x is equal to 3.45x plus 12.